Now here we want to look at simplifying some algebraic expressions, and I'll encourage you to watch my videos on fractions and all the operations involving with fractions, because those videos really set the tone or set the foundation for topics like these. Very important. So here we want to simplify two fractions. What do we mean when we say simplify that expression there? Simply mean we want to bring both of these fractions into one denominator, one common denominator. Alright, another way these questions are asked sometimes is they ask to express as a single fraction. So you want to combine these two fractions, meaning we want to have one denominator. So the denominator we normally choose is the LCM. So what's the LCM for 3 and 5? You're correct, it's 15. So as it stands now, we cannot add the numerators, because remember, we can only add numerators when the denominators for both fractions are the same. So we need to make them the same, and we normally choose to make them the same as the LCM. No, the LCM for both these values is 15, so we need to make this 15, so we multiply by 5. So we have to do the same thing to the numerator for the fraction to remain equivalent. How can I make this 515? Multiply by 3. And we have to do the same thing onto the numerator. So therefore, the 2x over 3 becomes 5 times 2x, that's 10x, over 15. And 2x over 5 becomes 3 times 2x, that's 6x, over 15. Now the denominators are the same, so we can go ahead now and add the numerators. 10x plus 6x and 10x plus 6x, that's 16x over 15. There is no number other than 1 that can go into both 16 and 15, so that's the simplest we can make the expression. Now here we have another expression, and again denominators are different, so we need to make them the same, and usually we try to make them the same as the LCM, and the LCM for these two denominators, 3 and 4, that's 12. So we ask ourselves, what can we multiply by the 3 here to make it 12? And that's 4, you're correct. But remember, we have to do the same thing to the numerator. So 4 times the numerator. But the bracket is important because the 4 is not just times the x, it's also times the minus 2. So it's 4 times the entire numerator. Here, we need to make this the same as the LCM, 12. So we have to multiply the denominator by 3 to make it 12. And we have to multiply the numerator also by 12. And the bracket is important because without the bracket, you're saying 3 times x. But it's not 3 times x alone, it's 3 times all of x plus 1. And hence the bracket is extremely important. So now, 4 3 is 12. So we can expand the bracket. So 4 times x, that's 4x. And 4 times minus 2, that's minus 8. Now, since this denominator is also 12, we can just extend it, because both of them over 12. So we can put the numerators together. And then expanding this bracket, 3 times x, that's 3x. And 3 times positive 1, that's 3. They have the same numerator, 12. So we only, same denominator, 12, sorry. So we only need one fraction there. So 12. So we group the like terms. So we have 4x. So 4x group with 3x. That's 7x. And negative 8 group with positive 3. What's negative 8 plus 3? That's negative 5. So 7x minus 5 over 12 is our solution.